Welcome to section 12.4. We are talking about infinite geometric series, and we looked at geometric sequences in series yesterday, and we're just going to expand on that. And a lot of the stuff we're doing today will be very similar to what we did yesterday. So let's take a look. What we want to start with is this idea that we're doing an infinite geometric series, and this infinite is super important. And we want to know what's the difference between infinite and finite. And we said finite yesterday was a specific number. We're adding up a specific number of terms. What does infinite mean? It goes on forever and ever and ever. And so that's the difference that we're working with today. So let's start with how to find the sum. Well, they give you this formula. The sum of the infinite series is the first term divided by 1 minus the ratio. And so we're still dealing with the first term in the ratio. Now, here's the huge stipulation. This only works if r is between -1 and 1. And that's what this means. The absolute value is 1. So when I take the absolute value, it's between -1 and 1. This is huge. If the ratio is not between -1 and 1, it's not going to be an infinite series. Okay? So let's keep going. Let's take a look. Find the sum if it exists. Well, let's start, and they're going to tell you to go to infinity, which is nice. This 60 is our first term. This 0.6 is our r. Is 0.6 between -1 and 1? And the answer is yes. Since it is, I can take the infinite sum. So I do my first term 60 over 1 minus r, which is 0.6. I stick this in my calculator and put parentheses. You end up getting 150. Okay? Let's take a look at number 2. What's different about number 2 is that we know the first term. We know that a sub 1 is 1, because that's the first thing they give us. But I don't know my r. And we said in order to find r, we take the second term divided by the first. -2/3. Now I want to check this. I take the third term, 4/9 divided by -2/3, stick those in parentheses. You again get -2/3. And I can kind of see as this is going on that I'm going to get the same ratio. So here's my r. And since I know the value of r, I'm looking at this value. This is -0.6 repeating. Is that between -1 and 1? The answer is yes. And since this is between -1 and 1, I can take my infinite sum. So I take my first term divided by 1 minus a -2/3, which is really plus 2/3. And if I stick it in parentheses, I end up getting 3/5. Okay, let's try one more. I can see again my first term, but I want to find my ratio. So -2/1 is -2. I might as well stop because I can't take an infinite series if my ratio is greater than 1. It's not possible. And so we say no sum exists because r is greater than 1. Good enough for me. Or the absolute value of r, because -2 is obviously less than -1, and that's the idea that we're trying to get through. Okay? Now we're going to give you an actual real-life example so that you kind of know what in the world an infinite sum means. So let's do that. A person is given one push on a swing. On the first swing, the person travels a distance of 4 feet. What did they just give you? A sub 1. On each successive swing, so on the next swing, the person travels 75% of the distance. This is our r. Now we want to say 0.75 instead of 75%, but at least there's the idea. What is the total distance the person swings before coming to rest? This is your key to let you know that they're asking for an infinite sum. Now, we want to talk about kind of what happens. We're going to write the first terms out. The first term is 4. To get the second term, I'm going to multiply by 0.75. And if I do that, I get 3. And then I'm going to multiply 3 times 0.75, and I get 2.25. Okay, now this went down a whole 1. This went down 0.75, the next one will go down less than that, and it's going to keep going down less and less and less amount. Is this geometric? We can say yes because we have a ratio of 0.75, or basically the idea is we're multiplying by 0.75 each time. Now, because r is between -1 and 1, I can find an infinite sum. So what I do is I take my first term divided by 1 minus my ratio, and what I get is 16 feet. Now, okay, so let's talk about the idea of why it's an infinite sum. The reason it's infinite, and I want to talk about it in terms of a picture. Okay, if you're looking at this swing, and let me give you this sideways view, here's where it's hooked to the top of your swing set, right? So your swing may start here. Well, as it swings, it's going to swing out this way, right? And then it's going to swing back. And the next time it's going to swing a little less, and then a little less, and a little less, and a little less, and it's going to keep going. Now, if you keep going 75% of the time, the question is, will you ever reach 0? This is actually like an exponential decay type idea where you get closer and closer and closer to 0, but you don't ever touch it. It's that idea. I can always continue to take 0.75 and multiply it. Now, will my numbers eventually get 0.00000000 blah, blah? Yes. I mean, at some point, they're going to get so significantly small that you're not really going to see the movement from our eyes, but there is actual movement. And so the answer is yes, this is infinite, because again, you can't actually get a whole answer of 0. You continually multiply by 0.75. Okay, so you continually keep going 75%. Now, is R acceptable? The answer is yes, because again, 0.75 is between -1 and 1. So kind of keep that in mind. This is kind of a tough thing to understand, and I'm going to try and point this out to you as to why it actually works later as we go through and in class, but this is the general idea. When you talk about 12.4, the other part that they do is an application, and the biggest part of 12.4 is how does this relate to real life? And we're going to show you a couple of different methods to do that, and the biggest way to get this to work is to practice. We want to start with this idea of a repeating decimal, because we want you to write your repeating decimal as a fraction. And so we're going to show you how to do that. The way this works, 0.47, if you notice, 47 repeats every hundredth. Repeats every hundredth. So every 2 decimal places. Now, hundredth is 0.01. Now, when I look at it to get the next one, I'm going to actually do 0.01 times another 0.01 to move it back 2 more places, or 0.01 squared. To move it back 4 spaces, I'm going to say 0.01 cubed to it, and you're going to keep going. The way this works then, because it repeats every hundredth, our R value is going to be 0.01. This is the idea of the hundredth. And what number gets repeated is 47, so that's considered our a sub 1. So is this R between -1 and 1? And the answer is yes. So what we can do is use our infinite sum formula, where we say take 47, which is our first term, times 1 minus 0.01. And I'm going to show you how this works. You end up getting 47 over 0.99. Oh, let me start this out. It's 0.47. I apologize. 0.47, because that's our first place. Now, you'll notice this is 2 decimal places in each term. So I'm going to multiply by 100, and I get 47 over 99. And the question is, if you can reduce it, you should. If not, we're going to leave it there. Okay? So our first term is whatever this starting value is, and then how many repeats it takes is what our R value is. So let's try another one, okay? If I look at it, here's my first term, because 63 gets repeated. So my a sub 1 is 0.63. My r value is how is it repeating? It's repeating every 2 decimal place. So it's repeating every 100th, which means my ratio is 0.01. Okay, so let's do this. The infinite sum then is 0.63 divided by 1 minus 0.01. So 0.63 over 0.99. And because these are both 2 decimal places, I'm going to multiply by 100. So 63 over 99 will, if it reduces, you should reduce. If it doesn't, leave it there. And it does reduce. You can divide each of these by 3. If you divide this one by 3, you get 33. If you divide this one by 3, you get 21. We can still go by 3's again, so I get 7 over 11. Okay, so if possible, reduce it. Okay, now this one I want to talk about too, because this one's slightly different. If you notice, where is our repeat? Our repeat is this 625, right? So I have to include this somehow. So what I'm going to do is I'm going to start my 8.8, and then I'm going to add it to whatever repeat I start with. Now your repeat always has to start with the decimal point. So our a sub 1 is going to be 0.0625. Okay? Our r repeats every 3, so every 1,000th. And since it repeats every 1,000th, it's 0.001. So here I go, 0.0625, 1 minus 0.001. All right, so 0.0625 over 0.999. Now if I multiply, in this case, this has 4 decimal points, so I have to multiply by 4, 1/10,000. So I get 625, and because I only need to go 3 places, this gets me 9990. I'm going to add that to 8.8 and put it in my calculator and give it a math fraction. And you're going to get some sort of fraction from there. You find that fraction for me because I don't have that number directly in my notes. Okay? Taking a look, a hot air balloon rises 150 feet in the first minute. What did they just tell you? A sub 1. During each succeeding minute, so next minute, it will rise 8% of its previous height. I don't know why this little thing's in there. But what they're saying, I'm not sure what they're trying to say here. You know what? I don't like the way this is worded. Here's what I'm going to do. We're going to do this as a warm-up in class so that I can fix this question because I'm not sure what happened to it there. So let's leave this one for a warm-up, and I'll show you the difference between a finite sum and an infinite sum. Okay? Same thing with the next one. We're going to spend the next 2 in class. So that's it for 12.4. Thanks for watching.